From the Earth to the Moon by Jules Verne. Chapter 9. The Question of the Powders. There remained for consideration merely the question of powders. The public awaited with interest its final decision. The size of the projectile, the length of the cannon being settled, what would be the quantity of powder necessary to produce impulsion? It is generally asserted that gunpowder was invented in the 14th century by the monk Schwartz, who paid for his grand discovery with his life. It is, however, pretty well proved that this story ought to be ranked amongst the legends of the Middle Ages. Gunpowder was not invented by anyone. It was the lineal successor of the Greek fire, which, like itself, was composed of sulphur and saltpetre. Few persons are acquainted with the mechanical power of gunpowder. Now, this is precisely what is necessary to be understood in order to comprehend the importance of the question submitted to the committee. A litre of gunpowder weighs about 2 pounds. During combustion, it produces 400 litres of gas. This gas, on being liberated and acted upon by a temperature raised to 2400 degrees, occupies a space of 4,000 litres. Consequently, the volume of powder is to the volume of gas produced by its combustion as 1 to 4,000. One may judge, therefore, of the tremendous pressure of this gas when compressed within a space 4,000 times 2 confined. All this was, of course, well known to the members of the committee when they met on the following evening. The first speaker on this occasion was Major Elphinstone, who had been the director of the gunpowder factories during the war. "Gentlemen," said this distinguished chemist, "I begin with some figures which will serve as the basis of our calculation. The old 24-pounder shot required for its discharge 16 pounds of powder." "You are certain of the amount?" broke in Barbicane. "Quite certain," replied the major. "The Armstrong cannon employs only 75 pounds of powder for a projectile of 800 pounds, and the Rodman Columbiad uses only 160 pounds of powder to send its half-ton shot a distance of 6 miles. These facts cannot be called in question, for I myself raised the point during the depositions taken before the Committee of Artillery." "Quite true," said the general. "Well," replied the major, "these figures go to prove that the quantity of powder is not increased with the weight of the shot. That is to say, if a 24-pounder shot requires 16 pounds of powder, in other words, if in ordinary guns we employ a quantity of powder equal to 2/3 of the weight of the projectile, this proportion is not constant. Calculate, and you will see that in place of 333 pounds of powder, the quantity is reduced to no more than 160 pounds. "What are you aiming at?" asked the president. "If you push your theories to extremes, my dear Major," said J.T. Maston, "you will get to this, that as soon as your shot becomes sufficiently heavy you will not require any powder at all." "Our friend Maston is always at his jokes, even in serious matters," cried the major. "But let him make his mind easy. I am going presently to propose gunpowder enough to satisfy his artillerist's propensities. I only keep to statistical facts when I say that during the war, and for the very largest guns, the weight of powder was reduced, as the result of experience, to 1/10 part of the weight of the shot." "Perfectly correct," said Morgan. "But before deciding the quantity of powder necessary to give the impulse, I think it would be as well— We shall have to employ a large-grained powder," continued the major. "Its combustion is more rapid than that of the small." "No doubt about that," replied Morgan. "But it is very destructive, and ends by enlarging the bore of the pieces." "Granted, but that which is injurious to a gun destined to perform long service is not so to our Columbiad. We shall run no danger of an explosion, and it is necessary that our powder should take fire instantaneously in order that its mechanical effect may be complete." "We must have," said Maston,
several touch holes so as to fire it at different points at the same time."
"Certainly," replied Elphinstone, "but that will render the working of the piece more difficult. I return, then, to my large-grained powder, which removes those difficulties. In his Columbiad charges, Rodman employed a powder as large as chestnuts, made of willow charcoal, simply dried in cast-iron pans. This powder was hard and glittering, left no trace upon the hand, contained hydrogen and oxygen in large proportion, took fire instantaneously, and, though very destructive, did not sensibly injure the mouthpiece." Up to this point, Barbicane had kept aloof from the discussion. He left the others to speak while he himself listened. He had evidently got an idea. He now simply said, "Well, my friends, what quantity of powder do you propose?" The three members looked at one another.
200,000 pounds,
at last said Morgan.
500,000,
added the major.
800,000,
screamed Maston. A moment of silence followed this triple proposal. It was at last broken by the president. "Gentlemen," he quietly said, "I start from this principle, that the resistance of a gun, constructed under the given conditions, is unlimited. I shall surprise our friend Maston, then, by stigmatizing his calculations as timid, and I propose to double his 800,000 pounds of powder."
1,600,000 pounds,
shouted Maston, leaping from his seat. "Just so.
We shall have to come then to my idea of a cannon half a mile long, for you see, 1,600,000 pounds will occupy a space of about 20,000 cubic feet, and since the contents of your cannon do not exceed 54,000 cubic feet, it would be half full, and the bore will not be more than long enough for the gas to communicate to the projectile sufficient impulse."
"Nevertheless," said the president, "I hold to that quantity of powder. Now, 1,600,000 pounds of powder will create 6 billion of litres of gas. 6,000 millions. You quite understand?"
"What is to be done, then?" said the general.
"The thing is very simple. We must reduce this enormous quantity of powder, while preserving to it its mechanical power."
"Good, but by what means?"
"I am going to tell you," replied Barbicane quietly. "Nothing is more easy than to reduce this mass to 1/4 of its bulk. You know that curious cellular matter which constitutes the elementary tissues of vegetables? This substance is found quite pure in many bodies, especially in cotton, which is nothing more than the down of the seeds of the cotton plant. Now cotton, combined with cold nitric acid, becomes transformed into a substance eminently insoluble, combustible, and explosive. It was first discovered in 1832 by Braconnot, a French chemist, who called it xyloidine. In 1838 another Frenchman, Pelleuse, investigated its different properties, and finally, in 1846, Schonbein, professor of chemistry at Bâle, proposed its employment for purposes of war. This powder, now called pyroxyle, or fulminating cotton, is prepared with great facility by simply plunging cotton for 15 minutes in nitric acid, then washing it in water, then drying it, and it is ready for use."
"Nothing could be more simple," said Morgan.
"Moreover, pyroxyle is unaltered by moisture, a valuable property to us, inasmuch as it would take several days to charge the cannon. It ignites at 170 degrees in place of 240, and its combustion is so rapid that one may set light to it on top of the ordinary powder without the latter having time to ignite."
"Perfect!" exclaimed the major.
"Only it is more expensive."
"What matter?"
cried J.T. Maston. "Finally, it imparts to projectiles a velocity 4 times superior to that of gunpowder. I will even add that if we mix with it 1/8 of its own weight of nitrate of potash, its expansive force is again considerably augmented."
"Will that be necessary?"
asked the Major. "I think not," replied Barbicane. "So, then, in place of 1,600,000 pounds of powder, we shall have but 400,000 pounds of fulminating cotton. And since we can, without danger, compress 500 pounds of cotton into 27 cubic feet, the whole quantity will not occupy a height of more than 180 feet within the bore of the Columbiad. In this way the shot will have more than 700 feet of bore to traverse under a force of 6 billion litres of gas before taking its flight towards the moon." At this junction J.T. Maston could not repress his emotion. He flung himself into the arms of his friend with the violence of a projectile, and Barbicane would have been stove in if he had not been bomb-proof. This incident terminated the third meeting of the committee. Barbicane and his bold colleagues, to whom nothing seemed impossible, had succeeded in solving the complex problems of projectile, cannon, and powder. Their plan was drawn up, and it only remained to put it in execution.
"A mere matter of detail, a bagatelle," said J.T.
Maston. End of chapter.